Okay, so today we're talking about change of variables, commonly referred to as UDU. This is one of the tools that we get, or that we have, I should say, that allow us to solve integral problems that we couldn't normally solve because we don't have a chain rule, we don't have a product rule, we don't have a quotient rule. If you don't like using an eraser, you're not going to like this. A lot of these problems are designed to be trial and error, meaning in order to solve the problem, you're going to have to try different things. And you might get partway into it and realize you chose the wrong thing, and you're going to have to erase and do it over again. That's the nature of the beast. There's no way around that. It's just how it works. So for those of you that don't function well in that environment, this is going to be a little bit of a struggle for you. They're not incredibly difficult, but they do take a lot of practice to get to start recognizing things. Gianna, what's the matter?
Is this 4.5?
It is 4 or 5, yes.
Okay.
So we're just going to dive into it. I'm going to start with a couple examples, and you'll see what I'm talking about here. So we want to take the integral of the square root of 8x plus 5 dx. Okay, it's been 2 weeks, so quick refresher. Remember, when you write an integral, you got to have the dx at the end of that because the dx tells you what your variable is. This is an indefinite integral, so we're not going to get a numerical value. Remember, this isn't an area under a curve. It's just a function that when you take the derivative of it, you end up with that. So notice, if we were doing a derivative, this would be a chain rule problem because we've got something underneath the square root symbol, and then you do the chain and all that other stuff. In a UDU problem, what we're going to do is we're going to choose a variable u. Commonly, we use u, but we're going to choose u to stand for something. It's going to represent something in our function. And the reason I started with this problem is because it's pretty easy to see what we're going to start with. We're going to make u 8x plus 5. And this is where it's a little bit of trial and error. You'll see in some of the other problems that other examples that I do today, there's a number of different things that you can choose for u. I mean, there is here too. I could have chosen u to be x. Well, that would be kind of silly. I could choose 8x to be u. I could choose u to be 8x plus 5. I could choose the whole thing to be u. It's just all kinds of weird different things to try. And you'll realize if you're right or wrong as you start working through the problem. Okay, so the procedure goes like this. You pick a u. I did that. Then you take the derivative of both sides. The derivative of u is just du. And the derivative of this side is 8 dx. So we're doing like an implicit differentiation there. You with me so far? Okay, so step 1, choose a u. Choose a u. Step 2. Step 3, solve for dx. Okay, so I'm going to solve for dx. I'm going to divide both sides by 8, so I get dx is equal to 1/8 du. Did I lose anybody yet? No. Good. Step 4, substitute. Go back to the original function, and let's start plugging in our values for u. So I'm going to turn this equation into Gesundheit. Gesundheit. U is 8x plus 5, so now I'm doing the square root of u. What's dx equal to? Well, dx is equal to that mess. 1/8 du. So just to save time, I'm going to move the 1/8 out in front and write a du there. Okay, that's the important step. Did I lose anybody there? Yeah.
Can you go over that again? Because that was weird.
This 8x plus 5 is u, so that became this. Then I need to substitute for dx. What is dx equal to? Well, we said that dx is equal to 1/8 du. And since it's a constant, I just moved it out in front. Okay? Now I do the work. I take the antiderivative of the square root of u. Go ahead. I'll wait. Quick refresher for you here. Square root of u. In other words, do this. John, what's the antiderivative of the square root of u?
Good question. I'm not answering now. I'm sorry.
I understand. Matters? What do you got?
2/3 u to the 3/2. Oh, I don't know after that.
I thought I heard it.
Plus c.
Plus c.
Oh.
Indefinite integral. Okay. So step 5, let me keep my colors consistent here. Step 5 is take the integral. And step 6, clean it up. By clean it up, I mean go back to the problem, get rid of the u's, and put in what we know that u stands for, and then we can also do some stuff like this is 1/12 times 8x plus 5 raised to the 3/2 power plus c. And there's our final answer.
Do you want us to mess it up or just leave it like that?
There's nothing to mess up there. What would you want to do to
Like, distribute the 112.
it?
Mess it down.
No.
Don't mess up.
No, because it's raised to the 3/2 power. You can't do that. I mean, you can, but it's ugly and nasty and not necessary. Senor?
So can like you do this problem without doing this? Or
Not that I know
if you chose a different u, would you?
Oh, hold on. It's a good question. Wait till we get to the next example, because we'll choose some wrong u's and we'll see how nasty it gets.
Wait, so how did you know this one is right? Yeah.
Because I'm smart. Well, process of elimination. The other choices that I outlined was, well, okay, let's make u equal to x. Well, does that make any sense? Because we just end up where we start, except x has become u. What if I make it u being equal to 8x? Then I have u plus 5. I still have a chain rule, which doesn't work. What if I turn the whole thing into u? So I just have u du. Well, that's not going to work because then I've got this nasty derivative over here that's not going to simplify me. Okay. There is a rule of thumb that we'll get to when you see the next example, and that is when you're done with step 4, if you have both u's and x's, you screwed something up. So after you substitute, if you have both u's and x's, you screwed something up. Question?
Yeah, I just missed the one part. Where'd the 1/12 come from?
Where'd the what?
1/12.
1/8 times 2/3.
Okay.
Okay, we having fun yet?
No, it's-
Let's move on. You have these 6 steps, right? Because I'm going to change screens. Okay. Number 2. The integral of, I can't read my own writing because I don't have my glasses on. 8x to the 5th minus 7 raised to the, what does that say? Help me out there. Old man.
9.
To the 9th power times x to the 4th dx. Now, if you're feeling saucy, you could multiply that out to the 9th power. Good luck. Okay, so here's where we start. Now, obviously, we realize it's got to be a u du problem because we have chain rule and product rule in the same problem, which don't exist for integrals, so we have to choose a u. So let's do this one wrong. Lucas, what would you like u to be? Don't pick the right u.
Do it the wrong way?
That's correct.
X to the 4th.
Okay, let's choose x to the 4th as u. He's feeling good about x to the 4th.
Being wrong.
That's wrong, right. I mean, that's wrong, correct. Yeah. But he's feeling good, and we don't want to stifle Lucas's dreams. We want him to spread his wings and fly. You can write this down if you'd like. It's entirely up to you. You might want to just be a sponge and absorb information. Okay, chose a u. Again, it's wrong, but we're pretending we don't know that. Take the derivative. Whoops. I've been on break also, forgive me. you will also end up doing the same thing because you're still not used to derivatives and integrals. Okay? Now substitute. So I know that, well, I've got nothing to sub in for that, so I'm just going to bring this down.
You forgot stuff.
What?
You forgot to
Take solve for
Oh, I forgot to solve for dx. Yep. Thank you. Sorry. There we go. I got nothing to sub in there. Oh, this is u. I got that. That's good. And then I know that that dx is that, so 1 over 4x cubed du. Okay? Now, yes, sir?
Why'd you put x to the fourth in the first term?
Because I made a mistake. Busted my chops. I can't get away with anything there. Eric, you could just say, why did you screw up? That was very nice of you. Thank you. I know you're concerned about my self-esteem, right?
It looked
Yeah.
worse than it started.
Yeah. Yeah, that's a train wreck. Okay? And so you see that the rule of thumb that I mentioned earlier, we have both x's and u's in the problem, and so therefore what we did was wrong. Way to go, Lucas.
A plus for you.
So this is the point where you say, okay, that's not right. I chose the wrong u. You use your eraser, you erase, and you start over. Lucas, pick another u.
That would fail.
No, it's up to you.
Oh. It's 8x to the 5th minus 7.
Now you want to do 8x minus 8x to the 5th minus 7, or that whole thing raised to the 9th. Can I talk you into raising it to the 9th?
Okay.
I'm just asking. This is America. You want to stay with that, or you want to raise it to the 9th power?
Let's do it then.
Raise it to the 9th?
Add on the x to the fourth.
He has put putty in my hands. Are you sure about that?
No.
No? How many people think you should raise it to the 9th?
Well, after
How many people think he shouldn't? How many have no clue what's going on right now? Excellent. We'll do it right, and this is the correct way to do it. If you raise it to the 9th power, you get a big, ugly, nasty derivative, and it doesn't work out so well. This is the correct u to choose. Du is equal to 40x to the 4th dx. This time I'll remember to solve for dx. Okay? And you can kind of get an idea that we chose well. I almost quoted Indiana Jones there. He chose poorly. When we do the substitution, u to the 9th, that's nice. X to the 4th, there's no sub for that. And then dx is equal to 1 over 40 x to the 4th du. So you might be saying to yourself, wait a second, he said that's wrong because there's u's and x's in there.
But there's not.
But they cancel, correct. And as you get better at this, you're not going to need this step. You're going to recognize it cancels right away. And you'll just go right to 1/40th times the square times the integral of u to the 9th du. The nice thing about these problems is that if you do choose the correct u, your integrals are fairly easy to do. That's not a bad integral. Right, Cole? What's the antiderivative of u to the 9th?
9 u to the 8. No, 10. 1/10 u to the 10th. Plus c.
Good. Okay, and then clean it up. 1/400th and 5th minus 7 raised to the 10th power plus c. Can you imagine having spent the time multiplying that thing out and then taking the antiderivative and realizing it's just that nice little thing? Okay. Any problems so far? You will, at some stage, pick the wrong u, but that's okay. Let's switch to 3.
Is there any trick to finding the right u?
Nope.
No?
Well, I shouldn't say that. There is, but you'll start to recognize those tricks as you do more and more of these problems.
So it just comes with practice.
You got it. Buried.
Just next.
Okay, I can't read that. What's the exponent there? Third. Thank you. Okay. Again, chain rule. Now we have quotient rule. Can't do that with integrals. U to U problem. Martina, what do you want U to be?
X to the fifth plus 3x squared.
Any particular reason you chose that as a U? Okay, good. That is correct, by the way. One thing you'll notice is that when you take the derivative of a polynomial, the power reduces by 1, correct? So if I take the derivative of a fifth power, I'm going to end up with something to the fourth, which just happens to be up there. You'll also get to the point where some of these problems seem so contrived because it works out so nicely. So she chose to use this stuff underneath. X to the fifth plus 3x squared plus 5. Okay, go ahead, solve that. That is the correct U, by the way.
But it makes the thing.
Dan?
If the whole thing is like to the third there, would you ever take that whole thing for you? Or just
You know, I seldomly use ever, but for the most part, no, you will not take the power. Because that's the idea. We're taking that thing out of there and reducing it to just U to the power.
Is it 5x equal 6?
You don't have to solve the whole thing. Just get it down to the point where you've got the antiderivative in terms of U, and then we'll stop. I don't think we necessarily need practice on taking antiderivatives right now. And then when you get your U antiderivative or integral set up, check with your neighbor to see if he or she has the same thing. Hey, how's it going? Good. That's okay. Talk to my therapist about it, I'll work it out.
Yeah, that's what I got.
Is that what Max?
Max? I thought you would hide by my hand. All the way. I hate Why did you do that?
I could have said low, but I chose mine. Those maxes are good. Yeah. Have those maxes are good.
One over U cubed or DU. Or like DU over U.
Okay, I'm going to do the extra simplifying step because some of you are still a little confused. du is equal to 5x to the fourth, excuse me, plus 6x dx. Now, you should notice that, strangely enough, that derivative is also the numerator of the function that we're working with. There's a reason why that's there, so that when we solve for dx, we get 1 over 5x to the fourth plus 6x du. And like I said, as you practice these more, you're not going to need the following step, but I'm going to do it anyways for those of you that are still confused. Okay, many of you will recognize that this then becomes 1 over u cubed du. Okay. But if you don't, that's okay. So we do our substitution. I have nothing to substitute in here yet, so I'm going to write that up on top. The bottom becomes u cubed, and then I sub in for dx. dx is 1 over 5x to the fourth plus 6x du. We get the canceling here, and therefore this becomes u to the negative 3 du. Okay. Any problems there?
We shouldn't go.
Should you bring it up with it?
You don't have to. I would, because then when I take the antiderivative, I would raise the power by 1, negative 1/2 u to the negative 2, sub it back in, life is good. Then move it back to the bottom because it's negative, and we don't want negative exponents. Yes, sir?
Why don't you leave u as 1 over u cubed and you simplify it to u to the negative 3? Does it matter?
Oh, why did I simplify it to u to the negative third?
Yeah.
Because eventually I would go ahead and take the antiderivative, and I would do that anyways to take the antiderivative. Okay, anything else? Are we good? Now notice, or what you should notice, or will notice, is that when you're picking u's, you have a couple different options. In general, this isn't always true, but it's a good rule of thumb. You want to choose the higher power for u. Do you understand what I mean by that? Notice the bottom here is a raised to the 5th power. The top is raised to the 4th. Your best bet is to start with the higher power because when I take the derivative of that, we're hoping it cancels with that. Basic, straightforward u du problems.
Would that be like an acceptable answer? Would you want us to go further?
No, because I haven't taken the antiderivative yet.
Okay.
Yeah, well, it depends on the problem. The problem might just say, do the u du substitution,
Okay.
do not take the integral.
But when it says this solve.
Yeah, solve, you gotta keep
Gotta
going.
go.
Yeah, I just didn't think we need to spend the time doing that. Okay?
Yeah.
Well, you know what else we're missing? What always comes first, or comes next when we're doing examples? No. Trig! Shut up. Let's do the integral of okay, here we go. How do we know it's a UDU problem? Well, it's because I've got chain rule and I've got product rule all wrapped up into one. Okay, this will be fun for all of us. Matt, what do you want to choose for you? Sine of 8x. Before I continue, I'm not going to tell you if it's right or wrong, but I will ask them. Did he choose wisely?
Oh, yeah.
No, I think
Because he chose the higher.
I don't think.
I don't understand.
All right, well, let's see what happens. Matt, what's the derivative of sine?
Cosine.
Good. And then don't forget there's a chain rule here, so I get that. For those of you that are haters, do you see that he chose wisely here?
Yeah.
Okay. Because now when we solve for dx, we get 1/8 times 1 over the cosine of 8x times du. This one I'm going to skip the extra step. I'm going to do my substitution, but I'm going to do my canceling as I do it. So this will become the integral. This is u to the 4th. This will cancel with this guy over here. The dx becomes a du, and I got to remember to put the 1/8 out in front. Boom. Well done, Matt. Okay, we'll keep going with this one. 1/8 times 1/5 u to the 5th plus c. That's 1/40th times the sine of 8x raised to the 5th power plus c. It's a quiz problem. You've got a little extra time. How do I know that that answer is correct?
No, use it to X's.
Hmm?
Maybe take the derivative.
There you go. Take the derivative. If I take the derivative of my answer, what should I get?
The beginning answer.
Beginning problem, correct. Now, more than likely, you're not going to have enough time on a test or quiz to do that, but it is an option there. Okay? Easy process? It's not necessarily easy, but does it make sense?
I guess.
Okay, one other quick thing I want to talk about, and that is even and odd functions. Tell me the difference between the two. What's an even function? sorry? Max?
So if it's like raised to an exponent, it's raised to 2.
That's it.
Okay, so that's how, so, wait.
And he gave it a shot.
No, he's not wrong, he's just not 100% correct. So you're saying all even functions are raised to the second power?
Well, no, like an even exponent.
Okay, so, oh, shh. So all the exponents have to be even?
Essentially, yes.
Well, essentially or yes?
Yes.
Yes. Yes?
Yes.
Yes?
No.
No?
They should be equal.
We just said do the
Is that an even function, Max?
Looks even.
Smells even.
I'm guessing it's not then? I don't know. Somebody-
You started this mess, how can you be confused? The rest of you, is this an even function?
Yes.
Yes, it is. Good.
Yeah, it is.
All right, Max, let's stay with you and see if you learned anything. Oh, Max, what's an odd function?
If it's raised to an odd number.
Is that an odd function?
Looks odd.
Outstanding. Oh, by the way, is that still even?
Oh, yes.
Why?
0.
Yeah, this is x to the 0, good. Okay, that's great, so now we can identify even and odd functions, that's helpful. Max, back to you. If I was to graph an even function, we'll just deal with even right now. If I was to graph an even function, what does an even function look like graphically? Mason.
An even function, it's two line, they go in the same direction. I don't know.
It's gonna be
So-
positive.
It's okay, Matt, it's
Not a horrible answer. Lucas?
Don't even functions go from negative to positive?
Meaning what?
Like they start lower and go, like,
No, those are odd functions. We'll get to you in a second. Eric?
Can't you mirror it across the y-axis?
Yeah, also known as?
Symmetric.
It has symmetry across the y-axis, so an even function would look like this. If it goes like something funky there, it's going to do the same thing over on the other side. Okay? So even functions are symmetric about the y-axis. So let's suppose I go from negative a to a, and I want to take the integral. One of the tricks you'll learn about even functions is that since it's symmetric about the y-axis, instead of finding the value from negative a to a, we could rewrite it and go from 0 to a and just double it. Okay, this is the harder one actually. Even's easy. Does that make sense? Okay, so in other words, we're going back to area under the curve here. So the area under the curve for this would be equal to the area under the curve for this, so just find one of them and double it.
Is x to the 6th plus x to the 5th still even?
No, that's neither.
Okay.
Okay. Max, back to you.
Oh, God.
What can you tell me about the graph of odd functions?
Oh, it goes from negative to positive like this.
Okay, which means what?
Can I phone a friend?
Sure.
Who would like to answer? Mason. Looks like he's got it.
Yes, Mason.
Could you repeat the question?
What does the graph of an odd function look like?
Oh,
Or
it's-
what's special about the graph of an odd
it's
function?
symmetry over
X symmetry?
and y.
X and Y.
X and Y, also known as
Or a half there.
origin. Right. So if I give you a picture of an origin symmetric, well, if I give you a picture of a function, how do you test if it's origin symmetric?
Plug in negative.
Too much work. Flip the picture over. It looks the same right side up as upside down. So something like this.
Well, yeah.
Okay. Now, suppose I go from negative a to a on this function. Okay, so that's even. Here's odd. What if I want to find the integral from negative a to a of that function g of x when it's odd?
When it equals 0.
Excellent. Tell me why, Mason.
Because you have negative area and positive area that are equidistant to 0.
Good. This area below would equal this area above. That's a negative area, that's a positive area, so it'll be equal to 0. This is a much more practical theorem than the even function. The even function is just a convenience thing. Instead of going from negative a to a, I'm going to go from 0 to a and double it. And a lot of times it's nice because plugging 0 into a function is a lot easier than plugging in a negative number. The odd thing is huge. If you can recognize that a function is odd when you take the integral, and you got to be careful you're going from the same values. Okay, it's from negative 2 to 2, negative 4 to 4. If you go from negative 10 to 2, that's not going to apply. They'll cancel out and give you 0. Is it the end of the world if you don't remember these two things? No, it's just a time saver. It's a convenience thing. Instead of grinding out some integral for an odd function, doing all the work and then realizing, oh crap, it's equal to 0, if you recognize it early on, you can save yourself some hassles. Okay? Yeah. Like I said, grind it out. Okay, so we've got the first day of 4 or 5. We're spending 3 days on this. This is a fairly important topic. And like I said earlier, it's something you need to practice, especially practice picking different U's and seeing what happens. And as we get more in-depth into the topic, you'll also see some weird situations that pop up, which we'll cover as we go over homework. Okie doke? Questions? Awesome. Thank you. That is all.